Mass percent composition from a chemical formula. The percent composition of a compound can be determined two ways. If we know the formula, we can calculate it. Or we can determine it experimentally, and that's what we're going to do on Thursday in lab. So we can calculate this from the formula, and we'll learn how to do that right now. So if we're going to do it that way, the percent of element X, again, is going to be the mass of element X divided by the mass of the compound. But we have to decide how much compound we're going to be looking at. And then you multiply by 100%. So let's do an example. Calculate the mass percent of fluorine in Freon 114, C2ClO4F2. Well, what is the mass percent of fluorine? The percent of fluorine will equal the mass of fluorine divided by the mass of the whole compound, and then multiply by 100. What's the problem, though? They didn't give us any numbers, did they? We actually don't need any numbers. What we do is we say, well, this percent fluorine is going to be the same for a small sample of this compound or for a large sample of the compound. It doesn't matter. The size of the sample doesn't matter, so we can choose a size that's convenient. If we just choose to look at 1 mole, it's going to be very easy to calculate the mass of 1 mole, right? Because we just use the periodic table. So what we do is we just choose 1 mole. I know sometimes, I remember as a student, I didn't like stuff like that. What do you mean? You have to pick something randomly out of the air. Sorry, this is how it works out sometimes. We'll just choose 1 mole. So then we need to find the mass of 1 mole of the compound. That's the whole thing, that's what goes on the bottom, right? So 2 times the mass of carbon plus 4 times the mass of chlorine plus 2 times the mass of fluorine. Two times 12.01, 4 times 35.45, plus 2 times 19. So 1 mole of the compound weighs 203.82 grams. So up here, that's going to go on the bottom, 203.82 grams. Because that's the whole compound. In that amount of compound, what mass of fluorine is there? 38. And it's just kind of sitting here waiting for you to pick it out. If you write out your calculation for the molar mass of the compound, all you have to do is look at your calculation and pick out the term that relates to the element of interest. So this was the mass of fluorine. There's 2, because there's a 2 in the formula. 2 times 19 is 38. So that's the mass of the fluorine. We can't just put 19 up there, because in each mole of Freon 114, there's 2 moles of fluorine. So 38 divided by 203.82 times 100. How many sig figs should we give this guy? I say 4. So 18.49%, I'm sorry, I don't know where that came from. 18.64% is fluorine by mass. I chose 4 significant figures because I was using molar masses that were rounded to 4 significant figures. And so since those are the basis of the calculation, that's reasonable for the answer. Any questions? This is kind of interesting. I don't always go into all of these, I forget what your book calls them, topics in chemistry or whatever they are. I would encourage you to read them because they help you to see how chemistry relates to everyday life. Your everyday life is full of chemistry. You just may not be noticing it. But this one actually pertains to a problem, so I'm going to just mention it a little bit. So they've done studies, and they believe that fluoride strengthens your tooth enamel, which helps your teeth to not have decay. So they add fluoride to drinking water in many communities. But you don't want to get too much fluoride because, as with everything, too much is not good. Too much can cause your teeth to get brown and spotted. That's not good. If you have even higher levels, you can have skeletal fluorosis, which is going to mess up your bones, and that's even worse. And so they figure that a reasonable level is about 1 to 4 milligrams per day for adults. So it has health benefits at that level, but too much is not good. And so if an adult drinks 1 to 2 liters of water a day, then they would receive the correct amount of fluoride in the water. So that's all lead up to this question. How many grams of sodium fluoride should be added to 1,500 liters of water to fluoridate it at a level of 1 milligram of fluoride per liter, so that an adult drinking 1 to 2 liters of water a day would get the correct amount of fluoride? So you can see this is not an ideal delivery system, because what if you drink more water, or what if you drink less? But that's beside the point of the problem. So the question that they're going to ask us first here is, what's the mass percent composition of fluoride in sodium fluoride? So we just learned how to do that. So let's sneak that into this little area here. We need the percent fluoride in sodium fluoride. Well, what's the mass of sodium fluoride? We're going to choose 1 mole. It's going to be 22.99 for the sodium plus 19 for the fluoride. So that's going to end up being 41.99 grams. That's funny. It's supposed to be period. What's the mass of fluoride in this? It's the 19. So we've got 19 grams of fluoride in 41.99 grams of sodium fluoride times 100% to make it into a percentage. 19 divided by 41.9. I'll do that right. 99 times 100. I'm going to express this to 4 significant figures, 45.25%. Okay? I'm pulling that just from the formula. Given any chemical formula, you can calculate the percent of one of the elements, or all of the elements. So how many grams of sodium fluoride? Let's pick this question apart. So we're given 2 numbers here. 1,500 liters of water and 1.0 milligrams of fluoride per liter. And they're implying that that is per liter of water. They gave me 2 numbers. 1 I'm going to start with, and 1 is going to be the conversion factor. Which one is the conversion factor? The one that has per in it, that has 2 units. Milligrams of fluoride per liter of water. That's a relationship, that's a conversion factor. So I'm going to start with liters of water. This conversion factor has liters of water in it. That would allow me to convert to milligrams of fluoride. Where am I trying to end up? Grams of sodium fluoride. Right, that's the question. How many grams of sodium fluoride? Well, now we've gotten from liters to milligrams, so we're in the right direction, I think. We could do milligrams to grams of fluoride, right? Can we convert grams of fluoride to grams of sodium fluoride? We can. We're going to use this percentage. That tells us 45.25 grams of fluoride per 100 grams of sodium fluoride. So that's our conversion factor for this last step. I need space. I wish I could do that in my house. Need room for the kids' clothes, just cover up the stuff. There's just maybe some sort of an invention in there. Okay, so I made a path, I made a plan. So I'm going to start here with 1,500 liters of water. I want to convert that to milligrams of fluoride. And so I need to divide by liters of water so that those units cancel out. From milligrams of fluoride, I want to go to grams of fluoride. Milligrams is on the bottom, and those units are going to cancel out. From grams of fluoride, I'm going to go to grams of sodium. Right? Went too far. I swear I'm telling it to go in the correct direction, and it's just not cooperating. And the resume button is gone. I'm so sad. Ugh. $1,500 liters of water. Okay, that's 1,500 liters of water, and then we were going to go to milligrams of fluoride, and then we were going to go to grams of fluoride, and then we were going to go to grams of sodium fluoride. So I'm just going to put all my units in there. Okay, so milligrams of fluoride per liter. That was given to us in the problem. It was 1.0. Grams to milligrams. We ask ourselves, what does milli mean? Milli means 10 to the minus 3. I want to put that with gram. I want to put it on the top, not on the bottom. Because 10 to the minus 3 and milli mean the same thing. And then grams of sodium fluoride and grams of fluoride. Okay, what was that percentage? Is it 45.25? So 45.25% fluoride is what we figured out. That means 45.25 grams of fluoride per 100 grams of sodium fluoride. And that's the conversion factor we need for this last piece. So 100 grams of sodium fluoride and 45.25 grams in there. It's a mess. If you want to see the unmessed up version, I did it better this morning. So for several reasons, this should have 2 sig figs, so this is going to end up being 3.3 grams of sodium fluoride. Any questions? Problems like this are not very difficult once you get comfortable with throwing units around.